Why is it essential to determine the quality of fit of a linear model? It's not just a question for academic curiosity. The answer lies at the heart of the effectiveness of machine learning and predictive analytics. Imagine you've just constructed a linear model. It's sleek, it's elegant, but does it do the job it's supposed to do? Does it accurately predict outcomes based on the input data? The only way to know this, to really know this, is by determining the quality of fit of your model. Determining the quality of fit isn't a process shrouded in mystery. It's a systematic, step-by-step method that provides clarity and purpose to your linear model. Step 1. Plot the residuals. A residual in this context is the difference between the observed value and the value predicted by the model. If the model fits well, the residuals will be randomly scattered around the horizontal axis. Step 2. Conduct a residual analysis. This involves checking the residuals for patterns. A perfect model would have residuals that are randomly scattered with no discernible pattern. Step 3. Use statistical measures. There are several statistical measures available to assess the goodness of fit. R-squared, also known as the coefficient of determination, is one of them. It represents the proportion of variance in the dependent variable that can be predicted from the independent variable. Step 4. Cross-validate the model. This involves splitting the data into a training set and a validation set. The model is then trained on the training set, and its predictive performance is evaluated on the validation set. These steps, followed diligently, will give a clear picture of the quality of fit of your linear model. It's not just about getting a model up and running, it's about ensuring that the model does what it's supposed to do and does it well. To summarize, determining the quality of fit of a linear model involves plotting the residuals, conducting a residual analysis, using statistical measures such as R-squared, and cross-validating the model on a validation set. This process is not just a formality, but a crucial step in ensuring the effectiveness of your model. Remember, a model is only as good as its fit. It's not just about constructing a model, but about fine-tuning it, testing it, and ensuring it's up to the task. And that's the beauty of machine learning. It's a process of continuous learning and improvement. It's about striving for that perfect fit, one model at a time.